All right, this video will cover nth roots and rational exponents. The goal is that you can evaluate nth roots and using both radical and rational exponent notation. So just a little root review. The first one was just to show you the main difference between squaring something with parentheses and squaring something without parentheses. But review 6 squared means 6 times 6. So that's not 6 times 2, but it tells you to multiply it by itself, so 36. Negative 5 squared then would be negative 5 times negative 5, so that would be positive 25, written with the parentheses like that. Now this one you have to be careful because this is like a negative 1 times a 9 squared. So really this is negative 1 times 81. So without the parentheses, sometimes we're given negative 81 because of this reason. Now, what's the reverse of square rooting, or what's the reverse of squaring a number? Would be taking the square root. So if 6 squared equals 36, then the square root of 36 equals 6. And if negative 5 squared equals 25, then the square root of 25 could equal negative 5. However, since every time you square a negative number, it always equals a positive number. If you take the square root of a negative number, remember, then you're going to get an imaginary answer because there's no number squared itself that will give you a negative answer. This is just a little vocab for you. We call the number under the square or under the radical symbol the radicand. And then the small number here is the index. And the definition then is what times itself, index number of times equals the radicand. So what times itself 3 times equals 8, which is what we're looking for. So 2 times 2 times 2 equals 8. So the cubed root of 8 equals 2. Is basically another way of thinking of the definition here. But the index is a small one, the radicand is what's under it. This one I kind of talked about. Remember the square root of 25 is 5. If you have x squared equals 25, then you have 2 choices for x. You could either have x equals 5 or x can equal negative 5. If I just say what's the square root of 25, it's 5. And then remember, since if you square 5, you get positive 25. And if you square negative 5, you also get positive 25. So if you take the square root of a negative, there's no real number that is no real number squared equals negative 25. So the answer to a square root of a negative includes a imaginary. So the square root of negative 25 is 5i. And if you think about 5i squared, remember that's 5i times 5i. 5 times 5 is 25. I times I is I squared. Remember, I squared equals negative 1. So this is 25 times negative 1. That's why we get the negative 25. So the square root of negative 25 is 5i. A review on simplifying roots. Remember, you have to do the factor tree. So 90 is like 9 times 10. 9 is 3 times 3. 10 is 5 times 2. The goal is to get it down to the prime factors here. 3, 5, and 2 are all prime numbers as far as you can go. And then the square root actually has an index of 2. So they don't write the index here in the square root, but it's an index of 2. So to get out of the square root, you need a group of 2. So this will be 2, or a 3 comes out, and then the square root, 5 and 2 are left inside, so it's the square root of 10. Another way of thinking of this is that it's the square root of 9 times the square root of 10. The square root of 9 is 3. The square root of 10 is irrational. So I'm going to skip B. It's the same thing. Break it down. Take out groups of 2. So just for time here. You can also do this with variables, and so I'll show you how that's done. I'm going to do D over here. 20 break down with the factor tree. That's 5 times 4. 5 is prime, but 4 is 2 times 2. So I can take out a 2 out front. Then the x's, I have x squared, so there's a group of x's here that can come out. And then for the y's, I have 5 y's, y to the 5th. And we need groups of 2 because it's a square root, so I can take out 1, 2 y's. So that's y times y, so on the outside it'd be y squared. Square root, you have a 5 left and a y left. So on the inside it would be square root of 5y. So 2xy squared square roots of 5y would be that simple expression for D. If you want to try this one, you should get 4a square roots of a is the answer for C. Cubed roots are similar, except for that, remember, to cube something means to multiply it by itself 3 times. So like 2 cubed is 8. So that means that the cubed root of 8 equals 2. So for a cubed root, you need 3 copies. So you need 2, 2, and 2 to get out equals 2. So essentially you can simplify them the same way, but instead of groups of 2, you need groups of 3 to form a perfect cube, to get out of the radical. So for example, 80 is 8 times 10. 10 is 5 times 2. 8 is 4 and 2, and 2 is 2 and 2, or 4 is 2 and 2. So I have, if I think about, move this one down a little bit here. If I think about what's left here, I have my factors, my prime factors here. 2 times 2 times 2 times 5 times 2 will equal 80. Which means that I have a group of 2's I can take out. There's 3 2's here. So I could say that's equal to 2 on the outside, and then cubed root, and 5 and 2 stay in there. So 2 cubed roots of 10 is how that would simplify. It works the same way with variables, except for you need groups of 3 as well. So 81 is the same thing as 9 times 9. And 9 is 3 times 3 and 3 times 3. So I have one group. 3 3's give me 27, and the cubed root of 27 is 3. So I can take out a 3. Now I have 5 p's. So 3 p's would give me p cubed, and the cubed root of p cubed is just p. So 1 p comes out there. And then for q, I have 3 q's, and the cubed root of q to the third is just q, so 1 q comes out. Then you have to remember to write the index for the cubed root. The index needs to be there, there's a little 3. And what's left in here, I have 1 3 left over and 2 p's, so it's going to be cubed root of p squared. Now with even roots, you can't have negatives under the cubed root because nothing times itself, if a negative times a negative, is always positive. So you can't take the square root of a negative number for that reason. However, for cubed roots, you have 3 of them. So the 125 is 5 times 5 times 5. 5 times 5 is 25, times 5 is 125. So the cubed root of 125 equals 25. Now the cubed root of negative 125 equals negative, or I'm not, sorry, not 25, 5. It equals 5. One group of 5. And so the cubed root of negative 125 equals negative 5. And if you think about it, it makes sense because negative 5 cubed would be negative 5 times negative 5 times negative 5. Well, negative times a negative would give you positive 25, and then 25 times negative 5 would equal negative 125. So since negative 5 cubed equals negative 125, if you go backwards, so the cubed root of negative 125 is negative 5. So odd roots you can have negative under, even roots you can't. Or you can, but you get an imaginary answer. So I'm just going to go down here to the fourth root. Fourth roots then, like 2 to the 4th power, means 2 times 2 times 2 times 2. Well, that's 2 times 2 is 4, times 2 is 8, times 2 more is 16. So then the fourth root of 16, if we go backwards, that'd give you 4 2's. So the fourth root of 16 is 2. So in order to get out of a fourth root, you must have a group of 4. Now, if you thought about these as all being negative 2 to the fourth, negative times a negative would be positive 4, times a negative would be negative 8, times another negative, you'd still get positive 16. So no matter what number you have in your to the fourth power, it'll always be a positive answer. So if you simplify, like the fourth root of 81, you need a group of 4. So 81 is 9 times 9, which is 3 times 3, which is 3 times 3. So here, the fourth root of 81 would equal 3, because 4 3's equal 81. So that goes backwards there. Now the fourth root of negative 81, even if all the 3's were negative, it would not give you a negative 81. So since I have an even root and a negative under a negative radicand, so an even index and negative radicand equals imaginary answer. So this is going to give me the answer of 3i. So 3i, not negative 3i. I didn't mean to write that. So the fourth root of negative 81 is 3i, not 3. So, okay. Now we're going to switch from index form to rational exponents. So going back and forth between the radical and a fractional exponent. This is how it works. The radicand is always the denominator of the exponent, and if the radicand has an exponent, then that goes in the numerator. So some ones that you should memorize, or like the common ones, are like the square root. So let's just say the square root of x. Or we'll use a, the square root of a. The square root of a is going to be a to the 1/2 power, because a has an exponent of 1, and the square root is a radicand of 2. We just don't write that 2 with the square root. It's like an assumed index. It's not written, but we must know that it's there. And so then the 1/2 is the square root. So square root goes with 1/2 power. Cubed root, same idea, would go the same as a to the 1/3 power. And then fourth root of a would be a to the 1/4 power, and etc. So fifth root of a would be a to the 1/5 power. These two particular ones you should be familiar with. Anytime you see a square root, you should know that's the same thing as a 1/2 power. So if I said, what's 16 to the 1/2 power? You'd know that's the same thing as the square root of 16. You'd be able to tell me it's 4. Something like that. Being able to recognize you can go back and forth between these two forms is going to be the goal for this unit. So the square root of 7 can be rewritten as 7 to the 1/2 power. The square root is the 1/2 power. Number 2, we have the cubed root of 2, and then raised to the 2nd power. So this one is going to be 2 to the 1/3 power, because in here you have 2 to the 1st raised and the cubed root. So the root, the radical, always goes in the denominator. And then that's squared. And then remember, if you have a power raised to a power, you multiply the exponents. So 1/3 times 2 is going to be 2/3. So really this is 2 to the 2/3. 2 to the 2/3 power. You could have rewrote this right away as the cubed root of 2 squared, and then went right from there, where the radicand becomes the denominator and the exponent becomes the numerator of your fraction. So this is the same thing as the cubed root of 4. So cubed root of 2 squared is the same thing as the cubed root of 4. cubed root of 5, that's 5 to the first power, so it's 5 to the 1/3 power in fraction form. 15 to the 5th and the 6th root of that. Well, that's going to be 15. The 6 goes in the denominator, and then the exponent goes in the numerator. So in fraction form, it's 15 to the 5/6 power. Let's go backwards. 3 to the 1/2. That's going to be the square root, because the square root has a radicand of 2, of 3 to the first power. So square root of 3. 5 to the 2/3. The 3 is in the denominator, so it's going to be the cubed root, and it's 5 to the second power. You could either write that like this, 5 squared, or the cubed root of 5 and then squared. So either one works, or you could write it as cubed root of 25. Okay? What we need to remember is that the nth root of a to the x is equal to a x to the n power. So whatever the index is always in the denominator. So the 1/4 power is the 4th root of 6 to the first power, which is just 4th root of 6. 5/6 power would be the 6th root of 14 to the 5th power. Or you could write that as the 6th root of 14 to the 5th power like this. Either one is, these are equivalent statements. And when we evaluate them, it's going to be easier to do the root first and then the exponent. So you're dealing with smaller numbers. Like this. So 625, I remember that's a perfect square. It's 25 times 25. So if I'm going to do a 4th root, I'm looking for groups of 4. 5 times 5, 5 times 5. Got 4 5s. So the 4th root of 625 is 5. Remember that if you have an even index and a negative radicand, then you have an imaginary answer. So the 4th root of negative 625 would be 5i. Then we need to remember that these are very similar. The negative 81 to the 1/4 power is the same thing as the 4th root of negative 81. Or the 4th root of negative 1 times the 4th root of 81. Since the 4th root of 81, since it's 9 times 9 and 3 times 3, got 4 3's here. The 4th root of 81 is going to equal 3. The 4th root of negative 81, since it's an even root, it's going to be, oh, I wanted to put negative. It's not negative, it's going to be 3i, imaginary. Okay, hopefully you can't hear the announcements going off. It's kind of loud here, but give it a second maybe. I paused it just as it stopped. So anyways, back to this. Okay, so we want to evaluate these without a calculator. So, you know, this test will be no calculator, so be prepared for that. The key here is do the root first and then do the exponent. So do the root and then do the exponent. So remember that you got to go, the nth root of a to the x power is a to the xn as the exponent. So if you go backwards, whatever's in the denominator is your root. And then whatever's in the numerator is your exponent. So this is going to be, negative 27 to the 2/3 will be the cubed root of negative 27 and then that squared. So the cubed root of negative 27 and squared. Remember, you can have a negative under a cubed root. And the cubed root of 27 is 3, because 3 times 3 times 3 is 27. So a negative 3 times negative 3 times negative 3 is negative 27. So evaluating the root first is going to be helpful. So the cubed root of negative 27 is negative 3. And then squaring it. Negative 3 squared is 9. So if you would have done that in the reverse order, you would have had to take the negative 27 squared and then try to find the cubed root of that. You can do it in that order, but I don't know what 27 squared is off the top of my head, so without a calculator it would be very challenging. The difference between the first example and the second example is that this is giving you the cubed root of negative 27 without the parentheses. So technically this is supposed to be negative 1 to the 2/3, 27 to the 2/3. I think you end up getting the same answer. Actually, you might get a positive. Let's see what happens. So this is the cubed root of negative 1 squared. Oh yeah, our answer was positive. And then the cubed root of 27 squared. And this would be negative 1 squared is 1. And this will be 3 squared is 9. You still get 9. But the difference between with the parenthesis and without the parenthesis. Remember our negative exponent rule. I'm going to just do the second one here for time's sake. This video is getting a little long. Negative 32 raised to the negative 3/5 power. So remember our negative exponent rule. You have to take the reciprocal. Now you only make the exponent positive when you take the reciprocal. So you don't change the fact that it's negative 32. It just moves from the numerator to the denominator and becomes positive 3 square root, or 3/5. Now that is 1 over the 5th root of negative 32, and then that cubed. So the 5th root of 32. So what times itself 5 times equals 32? I need my page extender here. So 32 is 16 times 2. 16 is 4 times 2. Oh, 4 times 4, I'm sorry. And 2 times 2, and 4 is 2 times 2. So we actually have 5 2's. And since it's negative and it's an odd root, your answer is going to be negative. So it's the 5th root of negative 32 is negative 2. And negative 2 cubed, well, that's negative 2 times negative 2 times negative 2. It's going to be negative 8. And so this is negative 1/8 is my answer for that one. All right, solving. Now we solved cubic equations and some power functions, some rational functions in an earlier unit, and we really dug deep and found all of the roots. Now, these we're just looking for the real roots. So we're just going to use our inverse operations. We're going to isolate our power. X cubed equals 125. So what's the reverse of cubing something? Taking the cubed root. So we cube root both sides here. We get x equals cubed root of 125. Remember, since that's 5 times 5 times 5, the cubed root is 5. That's really only 1 out of 3 answers, and we know this because we've solved these equations for all of the roots in previous unit. Because if you had this x cubed minus 125 equals 0, now this is difference of cubes. Remember, we'd factor this as x minus 5 and then x squared plus 5x plus 25, and you'd get your first real answer as x equals 5, and then you would use quadratic formula to get your other 2 imaginary answers. So really we're making this a little simpler. We're just practicing the inverse operations and solving for the real solutions. Here we're just finding x equals 5 by doing the cubed root. So the goal then is to isolate the power. So first here we have to divide by 3, and you get x to the 5th would equal negative 1. And then the opposite of the 5th power would be the 5th root. So the 5th root of negative 1 would be negative 1, because negative 1 times itself 5 times equals negative 1. Again, isolate the thing that has the root to it. So this one has 2 steps before I can take the cubed root. So first I'm going to add 3 to both sides to get this here by itself. And negative 19 plus 3 will be negative 16. Then I want to divide by 2. So just following your standard algebra order of operations here, inverse operations. Oops, I changed this from a cubed root to a square root by accident. All right, now that I have what's being cubed by itself, here's where I can then take the cubed root. So the cubed root of both sides. The cubed root of the left, that cancels out that cubed. So I'm going to get x plus 4 equals, cubed root of -8 will be -2, since -2 times -2 times -2 is -8. And I have one more step to finish solving. Since it's plus 4, I'll have to subtract 4 on both sides, and I get x equals -6. Last example, start by adding 7 to get the fourth root by itself. So you get x to the fourth equals, this is going to be a 10,000. Yep, 9 and then 3 zeros. So then the fourth root will undo the fourth power. And let's see. I have, this would be 100 times 100. And 100 is 10 times 10. So the fourth root of 10,000 will be 10. Except for that, remember with even roots, I meant to put x, not x to the fourth. You have two answers. Just like when you square root something, you get plus or minus. If you fourth root something, you get plus or minus as well. Because if you did -10 times itself 4 times, you would get positive 100 here times a positive 100 here, and that would equal positive 10,000. So you're getting those two answers. And so if you're doing the reverse, you have to account for that. You're getting positive 10 and -10 as a solution. So if you have an odd root that you're taking, you're getting one answer. If you have an even root that you're taking, you should be getting two answers. Here again, we're just finding the real solutions for these equations. So as you know, there are more solutions, but we've already covered that in a different section. Okay, so this is what you really need to be familiar with. And then remember when solving, isolate the power first and then take the appropriate root. So if it's a cube, if it's a x cubed, take the cubed root. If it's x to the 7th, then we're using the 7th root, which means that you need groups of 7. You probably won't see that, but just throwing it out there. All right, thanks for watching.